All right, class. We are looking at Newton's second law. We've talked about mass. We've talked about time. We've talked about position. We've talked about ratios and products of these three things to come up with new things like speed, velocity, acceleration, net force. I want you to see that all these things are connected to one another. So what's the next thing that we want to talk about? We want to talk about Newton's second law. But before that, let's again present or represent. That's some horrible writing right there. Newton's first law, or the law of inertia. Now, why do we even talk about Newton's first law? Why are we even bringing this back up? Or why are we even bringing up the law of inertia? Well, the law of inertia basically is talking about an object's resistance to its change, or resistance to its state. An object's resistance to you changing its state, or to something changing its state. Basically, an object wants to remain at rest, or an object wants to remain in motion in a straight line unless it is acted upon by some external force. That's Newton's first law. Newton's first law, again, I'm going to state it. Newton's first law, an object that rests, y'all go ahead and say it with me. An object that is at rest tends to remain at rest, or an object that is in motion in a straight line tends to remain in motion in a straight line unless we act upon that object with some external force. Don't care what that force is. It could be wind, it could be your hand, it could be a car, it could be anything that can push or pull an object. All right? Common sense. I know it's common sense to you. Just breaking it down. This is going to lead directly into Newton's second law. Newton's second law, before we do that, let's go ahead and draw our object. This object has some mass. All right? We're going to apply a net force to this object. I'm going to call that net force. Let me write it down. Net force. I'm going to apply some net force to this object that has a mass m. That's going to produce some movement, and that movement is going to be in the form of acceleration. Okay? So let's just say that this object was at rest. We had to apply some force to it in order to get it to move. The object wanted to remain at rest. That's Newton's first law. Now, Newton's second law. Which I really can't conceive it without the first law. It's called the law of acceleration. All right? So the law of acceleration goes like this. It says that acceleration is just equal to the summation of, you know what, I'm not going to write it like this. I want to be a little consistent. We can write it as a ratio, but let's go ahead and go back and write it as a product like we did before. It's going to be the summation of forces. It's going to be the net force. The net force is the product of the mass and the acceleration. So I'm just going to put a multiplication sign in between there. It's the product of the mass and the acceleration. How do we write that? Well, the net force is like so. The summation of all the forces acting on our object under consideration will represent this vector. Okay? That's going to equal to our mass, which is just a scalar, times our acceleration, which is a vector. This is Newton's second law. You see, it comes directly from the idea of Newton's first law. I really can't separate them. We can separate them, but they're so connected. Okay? So that's Newton's second law. Law of acceleration. The net force is the product of the mass times the acceleration. And the net force is a vector.